So, there are two things which I wanted to do today. Okay, let me do the easier one, right. So, I have a grid world or friendly grid world. I have not drawn the grids. Okay, assume that there is a grid here, and I want to go from room 1 to room 2. Okay, there are two doorways. Which is the best way for me to do? No start state. You could start from anywhere in the room. What is the best way to go to room 1? Room 2, sorry. Depends on what? Huh? I am asking for policies. I mean, what do you mean it depends on the start state? Give me a policy in room 1 to go to room 2. Doesn't matter what start state is.
Which door you are distance to the
What distance?
Pick the closest door.
Pick the closest door. Okay, great. So, what should I do? Let us say split this difference here. Right. So, if I am below this, I will go down. If I am on this line, I will go right. If I am below this, I will go up. Right. So, this is my policy. Right. Likewise, I will go up here. If I am on this line, I will go right. If I am above this, I will go down. Right. So, this is my policy. All of you agree with this? Great. Now, if I tell you that my final goal is here, is the policy the same or does it change? How many of you say it's the same? Yeah, I mean the standard reward. I mean -1 for every time step, and when you reach the goal you get 0, or 1 if you reach the goal, and gamma discount factor, doesn't matter. Standard shortest path rewards, one of the two shortest path rewards.
-1 for all inside.
No, any step you take -1. If you need to know the reward, yeah. I am saying it's just the standard shortest path reward. The answer to my question doesn't depend on the reward function. It could be -1 for every state. It could be 1 with the discount factor of gamma. Right, 1 at the goal state and 0 everywhere else, and gamma is 0.9 or something, doesn't matter, whichever it is. Yeah. So, how many of you say that answer won't change? Well, I mean if you want to know the policy in room 2, it is okay. That is a policy in room 2. So, anywhere below this line you go up, that line you go right. Okay, so that doesn't matter, that doesn't change, right? Now we didn't ask about. So, what is the policy in room? How many of you say it will change? Okay, so people who didn't put their hands up for both questions, what is your opinion? You didn't? Huh? You couldn't?
I think it won't change.
Oh, I heard it as I couldn't raise my hand. I thought you had some problems with your shoulder or something. Okay. It won't change. Won't change. Darn it, nobody gave the right answer.
It depends.
So, if you think about the question of solving the problem, right, solving the problem of going to the goal state, this is actually right. So, it is basically that. Right, and it does not matter. I mean I can either go right or I can continue going up. So, this right or up is a matter of choice in this line, but I just chose to go right. Okay. Right. So, now there are two policies here, the weight policy for room 1 and a yellow policy for room 1. Which one is correct? Which one is optimal? Let me not say correct now. Which one is optimal? Yellow is optimal. I will say both yellow and white are optimal.
In terms
Depends on how you define your optimality. Right? So when you talk about this kind of hierarchical problems, so you have different notions of optimality, right? So you have something called hierarchically optimal, right? So what I mean by hierarchically optimal, so a solution is hierarchically optimal if I say that you have to search through policies, okay, you have to search through policies that respect this hierarchy. I will give you some hierarchy, right. So in this case, what is hierarchy? I want to solve any problem of going to room 2, going anywhere in room 2, I first use the sub problem of going out of room 1, right. I go out of room 1 and then I go to room 2. This is the structure, right. So I have to go out of room 1 and then I go to room 2. Obviously that is the only structure you can have here, but in general I am saying, suppose I want to go to the I do not know, say you want to go to your mess, right, and I say that the only way you can do this is first you have to go to GC, right, and first you have to go to GC and then from GC you can go to the mess. Right. There might be other shortcuts which you can get by going through the admin block or something like that, right, which I am prohibiting now, right. So there might be an optimal solution that takes you to mess without going through GC, but I have given you a hierarchical structure, right, like you gave me a hierarchical structure, right. How do you get to the gate? You said go to the bus stand, get a bus and then go, right. I could have thumbed a drive, right? I mean I could have actually gotten somebody to give me a ride outside the ICSR building. You have prohibited that policy, right. Sorry, yeah, whatever. So you have prohibited that policy, you have told me go get a bus here, right. So that is the what I mean by hierarchical structure. So consistent with the hierarchy that I have given you, what is the best that you can do, right. Notice that I am not asking you what is the best way I can solve each of the sub problem, what is the overall best I can do, right. So going back to here, right. So what is the best way I can solve the problem of getting out of room 1, just without any reference to anything else, what is the optimal, the best possible way of getting out of room 1? The white policy, right. So if I am hierarchically consistent with getting out of room 1 and then go to the thing, right, I could potentially have used the white policy and then use the yellow policy in 2, okay, that is a valid solution, okay. But overall among all policies that satisfy the hierarchy, that is not the optimal one in terms of overall cost that I am going to get. So doing the yellow policy in room 1 followed by the yellow policy in room 2 gives me something that is hierarchically optimal, okay. Following the white policy in room 1 gives me a solution where the individual components in the hierarchy are optimal, right, the individual components are optimal, but overall put together that is not the best possible solution, right. So for example, I have told you go to GC and then go to the mess, right. If I know that going to the mess is my ultimate ambition, right, I might try to cross the road over in front of ICSR and then walk in some kind of a diagonal, barely satisfying the definition of going to GC and then turn right, right. So I am going from here, right, that is GC. So from ICSR I say go to mess but go through GC, so you could possibly do something like that, right, that is hierarchically optimal. But if I say go to GC first optimally, so then you probably do this, right, and then from here now that you have reached GC, now go to the mess, then you will probably do this. So obviously this is not hierarchically, it is not optimal, right, because there is a solution which satisfies going to GC and going to the mess in a shorter time, overall shorter time than this one that I have solved, right. So, this is essentially solving individual components optimally, right. So, if I come up with a solution where the individual components are solved optimally, right, and then the overall solution is obtained by putting the individual components together, right, then I call that recursively optimal, right. So, given that all my sub problems are optimal, right, and the policies are frozen, what is the best can I do, right. So, I have to put together this optimal sub policies to find something that is best among those policies. So, this is a more restricted policy, right. So, the hierarchically optimal, what did I say? I have to respect the hierarchy, but I need not necessarily solve each component optimally. Overall the problem should be optimally solved. What does recursively optimal say? Okay, not only should I respect the hierarchy, but for each individual components in the sub hierarchy I should have an optimal solution. So, given that everybody under me is optimal, what is the best solution I can get? Okay. So, and the third, which sometimes called flat optimality, is essentially this solution we are talking about, right. So, I cross ICSR, get through the admin block and then find a way to get out there, right. So, that does not respect any of the hierarchical restrictions, right. It just looks at the most basic actions that are possible in this world and tries to find what is optimal, okay. So, usually flat optimality gives you a more quote unquote more optimal solution than hierarchical optimality, which in turn gives you something better than recursive optimality, right, overall cost wise, correct. So, which one should you look at, which is a better solution to have?
Depends on how much time you have on your hands. Yeah, how much how much computational power you can afford.
Computational power, okay. Anything else? Flat optimality, essentially, I mean, I have been from the beginning I have been telling you why hierarchies are useful, there are so much advantages to that and so on and so forth. For finding flat optimal policies, you will have to give up on hierarchy, right. So, yeah, so if you have enough computation power and everything, you can just ignore hierarchies and then solve everything from scratch, right. If you have enough computation power, you do not even have to use function approximation. Is that correct? Think about it. Anyway, so yeah, so but flat optimality is hard to achieve. So we are given up on that. So now the question is between hierarchical optimality and recursive optimality. Which one do you want to achieve? So people understand the difference between the three, right? Okay. So I can ask you questions on that in the exams.
But what will be flat optimality in this case?
Which case? This
Problem.
this case. Flat optimality is the same as taking the yellow policy. In this case it is the same, there is no difference. That is why I drew the Gajendra circle picture, so that you know that okay, that is flat optimal, that is hierarchically optimal, and that is recursively optimal.
Flat optimal, globally optimal. It is
Flat
the,
optimal is globally optimal, huh?
It is the optimal.
It is the optimal solution. I am still waiting for an answer. There was a question hanging. Hierarchical optimal or recursive optimal? Which is better? Recursive is better. Why?
Because it would be easier to transfer. Yeah, recursive has advantages.
Recursive is better because it is easier to transfer. And then anything else? What are the other advantages?
It's faster to do recursive as well. Hierarchical, you have to.
We can deal with smaller subs.
Sorry? Yeah, I will anyway need to remember this. See, recursively optimal, I still have to solve the whole problem. It's not that I am not solving the whole problem, right? But I can modularize it, as you were saying, right? So the learning horizon is a lot simpler in terms of solving recursively optimal problems, provided I have a way of learning to solve the entire problem by treating these solutions to the sub problems as actions themselves, right? So I need to have that infrastructure in place. If I have that structure in place, then I can go ahead and solve the sub problems first and then put the solutions together. If I don't have such a structure in place, then it becomes tricky. I mean, I can still solve the sub problems, but still I will have to look at the whole problem at the higher level, right? So that makes it a little hard. So so recursively optimal is great because it gels with many of the things we were talking about, right? So it allows you to do transfer, reusability and things like that. So why is it more reusable? Because if I am learning something that is hierarchically optimal, you saw that I learnt a weird policy to get to the Gajendra circle. So that is not how I would like to get to the Gajendra circle every time, right? So I really like to walk straight more often than not. Using the shortest path to get to the Gajendra circle will probably be more, might not be the best for any particular problem, not sub problem. For any particular problem, it might not be the best way, but across different ways of different problems for which I can use the Gajendra circle as a stopping point, maybe this will be the better one on an average, right? So it's always a good idea to solve these things independently, so that I don't have to worry about my TD error from solving the original problem propagating back to solving the sub problem. If you think of how I am going to learn, if I have to learn the yellow policy, that essentially means that the reward that I get here, okay, has to propagate all the way back to states here, right? Only then this will start getting updated to go out like that, right? So it becomes a little trickier learning problem, so longer horizon and stuff like that, right? But when do you want to learn hierarchically optimal policies?
When your solution reusability is less, but your problem has a good hierarchy.
No, when I am solving the same problem multiple times, I really want to get a solution for that, or my recursively optimal policy is really bad. It's possible. It could very well possible that there is this corner case where the optimal sub solution is really bad, right? So I would really like to get the hierarchical, for example, right? I put a laser beam there, right? So every time you get out like this and you try to go up there, you get burned by the laser once. Ironically, still the white policy is recursively optimal. Okay, but you don't want the white policy, you want the yellow policy here.
That might not be.
Isn't there like a whole spectrum of policies
Oh really? How come?
Because if I split the action of getting out of room into like two actions, get out of room through door 1, get out of room through door 2, and then optimize something.
That's hierarchical optimal. There's no spectrum here, right?
Yeah, but with Gajendra circle, it would be like instead of saying come to Gajendra circle, come to the upper half of Gajendra circle.
That's what. It's still not. That's still you are making it hierarchically, recursively optimal, but with more options.
Yes, because, but I keep splitting it, and at some point it becomes hierarchical. If I say
It comes to the point of leaving out the hierarchy itself, start splitting it.
No, he's still having the hierarchy, right? He's not still allowing it to go through the admin building. So he's still saying you have to use one of these ways of getting to the Gajendra circle, and then you can solve it, right? So in some sense, what you are essentially doing is you are increasing the branching factor of your hierarchy. So yeah, I mean, sure, but all that is happening is it still says recursively optimal till your options reach a continuum where it becomes hierarchically optimal. But it's not like there's a continuum of hierarchical and recursive. Essentially, there is a different qualities of policies that you can get that are still recursively optimal, and in the limit becoming same as the hierarchical optimal case. Yeah. But there is not necessarily a continuum of characterizations of things that are recursively versus hierarchical. Yeah, so I agree with what you say. I mean, it's But then why would you want to define so many hierarchies? So many sub problems.
Maybe at some division, we don't get a very bad recursive policy, but at the same time we get it's not too computational.
Great. So typically we would do that if it warrants, if it is warranted by the problem settings. For example, like this here, right? Now there is a laser there, and maybe making another door somewhere there and exiting through that is a safer option, right? So we can do that. But the point I wanted to make is, even with that laser thing there, the white is recursively optimal, right? And you don't want the recursive optimal policy in this case, because the value of the optimal policy is really bad. So you want to do something that is hierarchically optimal in this case.
In this case, the flat optimality is much better than the hierarchical optimal as well.
Here.
Yeah. Now with the laser on. So the flat optimal solution will be much better than the hierarchical solution.
In what way?
Because you'll actually exit from the region 2, the lower bottom. You'll exit through the door and then come back to the upper region. That would be the flat optimal solution.
Okay. So if I have any restrictions on room 2 as to what you have to follow, if I say room 2, this is the only action allowed to you, yeah, the hierarchical optimal policy will be bad. Right? If in room 2 I can say, okay, you can go, you have an option of going to either room 1 or going to the goal, then it becomes okay. It depends on how I define the hierarchy, like he is pointing out. Right? But if the hierarchy says only action here is go to room 2, okay, then it's a bad option. Yeah, you are right. Okay. So now people wanted a difference of what is the difference between flat optimal, hierarchical optimal in this world, right? I said it is the same, but once you put the laser, it is no longer the same. Right? So because in room 2 I have only the yellow action here, right? So if I am not in room 1, if I am in the bottom half of room 2, I am going to run into the laser. If I am in the top half of room 2, I am fine. But a flat optimal would be if you are in the bottom half, go to room 1 and then go back to room 2 at the top half. Right? That will be the flat optimal case. Okay. Right, so I can give you worlds like this and ask you what is recursively optimal, what is hierarchically optimal, and so on and so forth. Okay, good.